Good afternoon. This is the first of 2 or 3 short video lessons on sedimentary rocks. There is some light glare on the board right here. I'm hoping it's the only light glare we're going to get. There's really nothing I can do about it. I've tried adjusting the lights and it doesn't go away, but I don't think we'll have it on any other portion of the board, just this beginning stuff. So first we're going to take a look at the difference between bedrock and basement rock. Okay, so bedrock is basically just solid rock. Any occurrence of hard rock, often it's in the subsurface, sometimes bedrock is exposed at the surface, in which case we refer to it as an outcrop. So bedrock is just solid rock. By the way, everything that we're going to do in these lessons is also discussed in the narrated PowerPoints, but these are the notes that I will put on the board and we will discuss in class for about 1.5 weeks. Or in other words, 1.5 class periods. We will discuss sedimentary rocks. And I may clip some things out because we have video lessons for them. All right, so what do we see here in our drawing? We see a layer of limestone at the top. It says 15 to 25 MA, capital M, lowercase a. MA stands for millions of years in age, all right? So our limestone is 15 to 25 million years old. There's a sandstone beneath it, 25 to 35 million years old. And a limestone beneath that, 35 to 50 million years old. Now notice that there is this granite intrusion at a deeper depth, and it is 800 million years old. Okay, so all of the rock here is bedrock because it's all solid, but only the granite in this drawing is basement rock. So as we will discuss in a narrated PowerPoint, basement rock is a special type of bedrock. It is rock that is older. How old? Tens of millions to hundreds of millions or billions of years in age, and it tends to either be igneous or metamorphic rock. So in this drawing, our sedimentary rock layers at the top, they're not basement rock. They might be bedrock, but they are not basement rock because, first of all, they're sedimentary, so they can't be basement rock, and they're just too young in general. So that's our drawing to go along with the difference between bedrock and basement rock. Okay, so now we are moving and we are going to take a look at types of physical weathering. I guess we do still have some glare. Maybe if I zoom in a little bit, we'll zoom in and out. All right, maybe if I adjust the iris, there we go. I'm going to open the iris a little bit. Maybe the glare is not quite so noticeable. Okay, so now we're going to discuss briefly some types of physical weathering. We discussed these types of physical weathering in the narrated PowerPoint, but these are the drawings I put on the board to go along with it. So what are we looking at here? We're looking at a sandstone outcrop in the mountains, say in Maryland, or eastern panhandle of West Virginia, as you are heading from West Virginia University to Baltimore, Maryland. You're going on a field trip to look at metamorphic rock. You got to go all the way to Baltimore to find good exposures of metamorphic rock. But along the way, we stop and take a look at the sandstone outcrop. So what do you see there? Well, you see that checkerboard pattern. So there's an arrow pointing to that and the word joints. What are joints? They are fractures, cracks, openings in the rock that form naturally when the rock is exposed to the surface. So this sandstone body was buried at depth. Erosion took away everything on top, and now the sandstone body is exposed at the surface. So the confining pressure was released and those fractures form. So in your narrated PowerPoint, we're going to refer to that as jointing, or the formation of joints, natural fractures. What else do we see going on here? Well, we see a tree. It's in red because I don't have any green markers anymore. That is a tree or bush growing out of a fracture. That is root wedging. It's another type of physical weathering. So once these fractures or joints form, these other types of physical weathering will jump in and make those fractures larger. So can we form a little bit of soil in these fractures? Yes, we can. Can it support vegetation? Sure. And as the roots grow larger, as they're growing into the fractures, it kind of opens the cracks even more. Now then over there, a little further to the left, you see an actual opening, and then you see a blue line across representing that there's water in that fracture. That's going to represent frost wedging. So let's say that it's November, and the daytime temperature is, I don't know, 48 degrees, and it's raining, no, it's 45 degrees, and it's raining pretty heavily. Is water going to get into these fractures, these joints? Yes. Overnight, the temperature drops down to 30 degrees. Is that water going to freeze? Yes. You probably already know that water in the frozen form is less dense, meaning it expands. So every time you have one of these freeze-thaw cycles, it's going to open that fracture up a little bit more. We call that frost wedging. You're going to notice that on the far left is a block of sandstone that is now completely come out of the rock and is sitting there on the side. That is an example of what frost wedging can do with time. All right, so now what we're going to do, I'm going to move where I'm standing, and maybe the glare will go away, or it's just going to shift. The projector bulb is not even on, so the glare is not from that. It's from the window. The shades are already as good as they're going to get. So we see there a stream leaving the rock outcrop and heading down the hillside. And then we have sand grains in it because this is a sandstone. So another type of physical weathering is referred to as abrasion, or breakdown by material transport. These sand grains, as they're bouncing along in this stream, they can hit bedrock that's outcropping in the stream. They can hit other sand grains or pieces of rock and break into smaller and smaller pieces. All right, we're gonna move just a little bit more now, and we're gonna just add here that what else can be going on at this rock outcrop? Well, you can also get salt wedging, or the growth of halite crystals out of the groundwater into those fractures that will help to make them wider with time. And then thermal expansion, which has to do with heating and cooling, so expanding and contracting of the outer layers of rocks during forest fire events. Unfortunately, there are dozens of fires burning in the western states. It's terrible. Now, I noticed that the title of this, we're going to scoot back a little bit and just kind of look at the whole thing. Okay, so the title here is Physical Weathering. Now, in your narrated PowerPoint in the chapter, we're also going to briefly discuss chemical weathering. Now, I don't do any drawings for chemical weathering because I wouldn't know how to draw chemical weathering, but I'm simply going to mention that some types of chemical weathering that we will refer to in the narrated PowerPoint are also occurring here. So oxidation is occurring, dissolution or the dissolving of minerals is occurring, hydrolysis, by which groundwater forming a weak carbonic acid will help to turn some silicate minerals like feldspars into clay minerals. All those types of chemical weathering are also occurring here. It's just a given that they're occurring here. We're not going to try to draw them. They're on a much smaller scale. Okay, we have one more drawing for this particular video lesson. And again, I'm hoping the light glare will get better. It is a little bit better. Okay, so this is a particular type of physical weathering that happens to granite. It's called exfoliation. Okay, so this tends to happen to granite plutons when they get exposed at the surface. And yes, they're kind of bulbous anyway as they form, but the exfoliation is going to make these granite bodies become even more rounded when they are exposed to the surface. So what's going on here? Okay, so you see that thing that looks like a roller skate? That's a car. So this is a road cut. Looking at it from the side, imagine the road going into the board and coming out of the board, and we are driving into the board, and this exposed granite pluton is to the left of us. So we're driving, say, in the mountains here of North Carolina. Now you notice the checkerboard pattern there, checkerboard pattern. Those are the joints, the fractures that have already formed as this rock was exposed at the surface. Now, notice there to the right, I have an arrow pointing to the side of that pluton, and I've labeled it mountain face. Okay? The mountain face is the side of the mountain or rock that is facing you. So what happens here with exfoliation is that granite tends to split along joints that are parallel to the mountain face. So you see there that there's one nice joint or fracture that's close to the mountain face and it's parallel to the mountain face. And then you see in the top right corner what looks like a little sliver there, and there's kind of a point to it. Okay, that's where we have already had exfoliation of the outermost layers down closer to the road. So these granite tends to split along these joints parallel to the mountain face, and it tends to go from the bottom on up. And in the narrative PowerPoint, and also in class next week when we start this material, we're going to take a look at a couple of particular famous exposed granite plutons in Yosemite National Park, namely Half Dome. Okay, so I am going to stop filming at this point so that this will be a short video and easier to upload onto YouTube. And then we will pick up on the other boards with the next topic.